Okay, I just wanted to give a quick, I just wanted to record a quick video to show the difference between the indefinite and the definite integral. So we started off the chapter first talking about indefinite integrals, the one on top. Basically, to evaluate this is to answer the question, what are all the functions whose derivative will be x squared? So in this case, let's go to green. So in this case, the reverse power rule that we established earlier, any function that looks like x to the third power over 3. So if you were to take the derivative of this, the 3 pops out front, drops by 1, the derivative will be x squared. But since the derivative of a constant is 0, any function of the form x cubed over 3 plus c. And so to evaluate, let's call this number 1, to evaluate the indefinite integral is to find the functions whose derivative is x squared. Now, this week we're talking about definite integrals. Same symbol, but in terms of what it represents, it's different, but not entirely different. So when you see these limits, so we'll call this problem 2, when you see these limits of integration, that is an interval. So we're talking about an interval in the domain or interval on the x-axis 1 to 3. A definite integral is an area problem. So to evaluate problem 2 is to answer the question, how much area is bounded between the graph and the x-axis on the interval 1 to 3. So this is answering the questions. Here's the, nope, it's not exactly right. Here's the graph of x squared. Should hit the origin, something like this. There's a parabola. And we have the interval 1 to 3. And we're looking for this area. And so to evaluate this definite integral, well, we have to do two things. One, we have to find the antiderivative and then apply the fundamental theorem of calculus. So this should equal x cubed over 3 and evaluated from 1 to 3, meaning plug in 3 for x and then plug in 1 for x and subtract the 2. That's what the fundamental theorem of calculus is saying. So this should equal 3 to the third power is 27, and it's over 3, and then subtract 1 to the third power, which is 1 over 3. So this area in red over here should be exactly 26 over 3 square units. Again, we first approached this problem using summations and those summation formulas and limits. Taking the fundamental theorem of calculus approach is much more direct and less time consuming. Okay, that's it for this video.